Alright, welcome to this video review of our assignment number 12, double and half angle formulas. Now let's go ahead and get started. It says use the information given about the angle to find the exact value, and you're given 4 identity properties. Now let me go ahead and share something with you. These are known as double angles, and you're going to have identity properties for these two. And then these over here, these are known as half angles. And these half angles also contain identity properties. Both of these properties are going to be found in your green sheet. The more important thing that needs to be done is that I'm only given certain information to do with the angle. In particular, I'm only given 2 things. I'm given something important, which is quadrant where this angle lies, and I'm given one of the trig identities, which is here. Now, what is it that I need to still solve? I still need to solve. See, the thing is that all these trig identities, A through D, are actually the majority of them are going to be asking for sine theta and cosine theta. The only thing right now is these are kind of unknown values. The only thing I know is that tangent is equal to 1/2. That's the only thing I know so far. But this in itself, just this clue in itself, will give me the ability to solve these other things. Why? Well, let's go ahead and write down Sohcahtoa. Sohcahtoa is powerful. It's powerful in the sense that it gives you the ability to know with the triangle what values you need to come up with it in order to get an angle. For example, sine theta is opposite over hypotenuse. I do know opposite because remember, from this particular trig identity, I know this is opposite over adjacent, which means that in this case, before I even start, this is going to be 1. Well, actually, I'm going to write down what the real answer should be, -1. And this is, oh, hold on. I prefer that be in black. So let's go ahead and try that. Oh, it's not cooperating. Hold on. Let's see if it does it now. There we go. This is -1. And this is going to be, actually, this is adjacent over hypotenuse. This is going to be -2. Now, you might be asking, Sandoval, hold on. Wait a second. These are positives. How is it that you know they're negative? Well, that's because you need to draw the central angle to this. This right here, if you draw a unit circle, you'll find out that pi is here, and 3 pi divided by 2 is here, which means your triangle, remember, your triangle always starts from the origin and always goes to the horizontal line. So that's where your right angle always gets formed. This quadrant is always negative, which means that this is really, remember, this being your angle, this is your opposite, this is your adjacent, which means that in this case, this is -1, this is -2. Now, this is important because when you deal with other quadrants, quadrant 4, quadrant 1, or quadrant 1 is positive, quadrant 2 is positive, negative, you're going to have to, when you start thinking about opposite or adjacent, you have to go ahead and actually identify that. You know, identify which ones are positives and which ones are negative. But in our case, what's important to us is this quadrant here and this values. Now, what am I missing? I'm missing the hypotenuse sides. Actually, if you notice in both of these over here, only thing I need to really find out is what's the hypotenuse of that value and that value. Well, one value, and I'll be able to solve for the rest. But I could do that because I have Pythagorean Theorem. Pythagorean Theorem gives me the ability to say you got leg squared plus leg squared equals hypotenuse squared. Or in other terms, a squared plus b squared is equal to c squared. That's 1. This is 4. C squared, so you have 5 is equal to c squared. You take the square root of both sides. You find out that the c is equal to square root of 5. Now, it's going to be positive because remember, this is plus or minus. It's going to be positive because all hypotenuses are positives, which means that this is really the square root of 5 and the square root of 5. Now, it would be lovely if I could say we're done there, but we're not because we have to rationalize the denominator. We don't want to leave the denominator as a square root. So we do square root of 5 times the square root of 5. Wanted to gain some space, I'm going to erase this here. And I will now go ahead and continue the rationalization. It becomes negative square root of 5 times 5. And this is going to do the same thing here. Square root of 5, square root of 5. It's going to become -2 square root of 5 over 5. So now I have my other 2 values. I have my sine and cosine. Now the reason why that's important is because when I started with my question A wants to know what's identity property for sine, or double angle for sine of this. I could go ahead and pull out my green sheet. look at the identity property, and with confidently write down that this is sine 2 theta, cosine theta. And I know what those are. They're listed right above. 2 sine theta is negative square root of 5 over 5. Cosine theta is negative 2 square root of 5 over 5. This really looks like this. 2 times negative square root of 5. Well, actually, I'm going to go ahead and list it all kind of together in a way. Might make it easier for you. What I mean is I'm going to put the whole numbers with whole numbers. 2 times negative 2 times negative square root of 5 times square root of 5. Now these two negatives are going to become positive right off the bat. And at the bottom, I'm going to have just 5 times 5. You might be wondering, what about this 2? This 2 only belongs to the numerator. If anything, there's a 1 multiplying there that belongs to the denominator with that 2. But it's not important. What is important is my result. 2 times 2 is 4. Square root of 5 times square root of 5 is just 5. And as a denominator, this is 25. I end up getting an answer that says 20 over 25, which reduces to 4 over 5. And here's my answer. That's what my double angle of sine 2 theta is. Now let's move on to double angle of cosine 2 theta. Double angle of cosine 2 theta is going to follow something slightly different. Actually, there's 3 identity properties with it. I'm going to just use this one. Cosine squared theta minus sine squared theta. Does it make a difference which one you use? No. I'll give you different representations of the same answer. The same answer, actually. Now, let's go ahead and apply this whole thing again. Looking for my identity above, you'll have negative. Let me go ahead and write this a little bit neater. Negative 2 square root of 5 divided by 5 squared minus negative square root of 5 squared. Now, what happens here? Everything gets squared. Negative 2 squared, square root of 5 squared, 5 squared. Square root distributes to all of it. Same thing here. Negative 5 squared. And this becomes 2 squared. Hold on. Oh, wrote something down wrong. Do y'all notice that? I wrote this one wrong. So, because this is really 5. Okay. Which means that's 5 squared. Now, what is my end result? This becomes now negative 2 squared is just 4. Square root times 5 over 25 minus, let's see, this is going to become positive 5 over 25. Now, this is really 20 over 25 minus 5 over 25. We're just going to make an answer of 15 over 25, which actually is going to reduce to 3 over 5. So there's your answer for that one. That's for B. Let's go ahead and get into the half angles. I think C is the first one they're going to ask for. The half angle is going to be, in this case, let me go back up. Yeah, the sine one and then cosine. So sine half angle. So I'm going to go ahead and write down the identities for that one as well. So let's go ahead and deal with sine angle divided by 2. And write down, look at your green sheet, and write down the identity property. That's going to be plus or minus square root of 1 minus cosine theta all over 2. Now, I have a plus or minus. The first thing I'm going to do is figure out where does the angle lie. So I'm going to go ahead and write down my original angle, which was 3 pi divided by 2, and apply a half angle property. What do I mean exactly? If I want to make this into a half angle, that means I need to take the left side and multiply it by also a half, and take the right side and multiply it by a half as well. What do I do? I multiply all this by a half. And you'll produce 3 pi divided by 4. Now, where is that? Well, let's look at your unit circle. Find out that pi divided by 2 is here. And you're going to find out that in this case, 3 pi divided by 4 is going to be, actually, I think it's going to be right over here. If I'm not mistaken, it should be there. Let me just check on that, because I want to make sure that all our answers. Actually, no, let's correct this. 3 pi divided by 4 is actually this angle right over here. So now this is important because when we look at the sine value for this one in this quadrant is still positive. So this is going to be positive. What's going to affect us is on the other one. The other one is going to be negative. So let's go ahead and now just let's apply some of these properties. So it's going to be the square root of 1 minus cosine theta, and we said cosine theta was negative 2 square root of 5 divided by 5. Negative 2 square root of 5 divided by 5 all over 2. Now the first thing I'm going to focus on is on this value right here, that denominator. And what I'm going to do is going to go ahead and get rid of it by multiplying 5 top and bottom. Now when I multiply 5 top and bottom, this 5 is going to distribute this way. This will be a 5 there, and these 5s are going to cancel out. This 5 is going to multiply with that 2. So let's write our end result. This is going to be square root 5 minus, now, you see the two negatives? It's going to become positive. So I'm going to make that positive 2 square root of 5 over 10. Now, from here, I'll go ahead and break up the square root symbol. This is 5 plus 2 square root of 5 over square root of 10. So then from here, I'm going to multiply. I want to get rid of this square root of 10, so I'm going to multiply by square root of 10, top and bottom. And I'm going to be left with then square root of 5 plus 2 square root of 5. I'm going to combine. I'm going to put the 10 here. I combined the two square roots. That means I combined this one and this one. I combined them. They didn't cancel out. They just combined them. And these will cancel to produce 10. Now the only thing that needs to be left is just distribute this 10. And I'll get my final result as my answer. I'll get the square root of 50 plus 20 square root of 5 over 10. And this will be my answer for this question above. All right, let's do the last one, which is a half angle. We're going to do a half angle of D. The last one, D, is cosine of this half angle. So in this case, we're going to go ahead and use identity property, which is very similar to our previous, plus or minus square root, but in this case it's going to be 1 plus cosine theta all over 2. Now before I even start, one of the things I need to realize is that this angle, the cosines in here means that in this one it's going to be negative. You cancel out that positive, and it's because of this here. Cosine in this quadrant, remember this quadrant is negative positive. Cosine in that quadrant in itself is negative. So my angle, this I'm going to be looking at the negative portion of this. But it's going to follow something very similar to what we did above. And the reason being is because it's going to be now the negative 1 plus negative 2 square root of 5 over 5 all over 2. Same thing. Focus is going to get rid of this denominator. It's going to be achieved by multiplying 5 top and bottom. I'm going to distribute this. This 5 is going to cancel out with this. But the important part is that I will be left with a simplified solution, which is this 5 plus negative 2 square root of 5 all over, remember, 5 times 2, 10. So, a bit close to getting my solution. Now, what I'm going to do now is separate both of them. So I'm actually going to get 5 minus 1 plus. I'll keep it as a negative. I know some people are probably feeling uncomfortable. They're used to seeing minuses. For those people, I'll go ahead and put a minus. Nothing happened, just made the negative into a minus. Square root of 10 times square root of 10 top and bottom, because you rationalize this denominator. And we'll get the same thing. This is now going to become 5 minus 2 square root of 5. I'm going to go ahead and make this times 10. And at the bottom, I'm going to make that 10 as well, because remember, the square roots cancel out. And the only thing left to do is really distribute, which means that when you start solving this, or your final answer, actually better put, is going to be 50 minus 20 square root of 5 all over 10. And that's your answer. So now we actually have all 4 trig identity answers as far as half angles and double angles. Let's go ahead and move on to the next one. Next problem asks us to do pretty much the same thing, but now using sine. So let me go ahead and do that one as well for you as well. Now the same thing, I'm going to go ahead and first find out where this quadrant lies. Now this quadrant in itself, 2 pi and 3 pi divided by 2, that's 2 pi. This is 3 pi divided by 2. Which means that for this one, my triangle is actually going to be right here. This way and this way. And, or I'll highlight it real quick. It's my quadrant. It's my right angle, my opposite over adjacent. And in this case, since I'm given opposite over hypotenuse, hypotenuse is positive, the opposite is going to be negative square root of 3. So let's go ahead and actually start solving this. Remember, I'm given sine, I still need cosine, theta, which is still adjacent over hypotenuse from Sohcahtoa. I don't have adjacent, I do have hypotenuse, I know that's 3. And then I still need tangent. Tangent theta is opposite over adjacent. I have opposite, negative square root of 3. I don't have adjacent. What's unknown for those, but I could go ahead and solve it. And with this one, leg squared plus leg squared. This is the one I don't know. Well, I'll call it B, because hypotenuse squared. These right here are going to become then 3 plus B squared is equal to 9 minus 3 minus 3. Cancel out, B squared is equal to 6. Take the square root of each one and actually get B squared is equal to, or B is equal to square root of 6. So that means that this is really the square root of 6, and this is the square root of 6. Now the only one that needs adjusting is this one right here, because they can't have a square root as a denominator. This is all going to become then 6, because the squares cancel. On top, this is going to become negative square root of 18, which actually could be simplified some. For those that see this, this is really going to be negative square root of 9 times 2 over 6. I'm going to take these in slow steps. Negative square root of 9 times square root of 2 over 6. This is going to equal then negative 3 square root of 2. Now for those that are wondering where the negative 3 come from, that's the square root of 9, which is 3, and this is over 6. And this will be then negative square root of 2 over, this reduces to a third. So negative square root of 2 over 3. So this is going to be your answer for tangent. Now let's go ahead and actually apply all 3 properties. Okay, let's start with A. Sine to the double angle for this one is going to be equal to, let's see, 2, I think sine theta, cosine theta. Just let me double check on that. Yeah, sine theta, cosine theta. Sine theta I've been given already. I have 2 times, let's see, it's negative square root of 3 over 3. And cosine theta is going to be negative square root of 3, negative square root of 6 over 3. All right, good. So what is going to happen here? It's going to be 2 times, or negative 2 over the square root of 18. Or you could simplify if you want to over 9. Actually, you will, if you want this to be all the way right, you should simplify this. This is going to become the square root of 9 times the square root of 2 over 9, which is going to make negative 2 times 3 over the square root of 2 over 9, which means that you'll have negative 6 over square root of 2 over 9, which means that this all reduces to negative 2 over 3 square root of 2. And this will be your answer. This is your most reduced form answer. Now, if you provided this, that's actually pretty good. You went it pretty far. Now let's do B. B is we're going to do the cosine of the double angle for this one. I'm going to use cosine squared theta minus sine squared theta. So when I do that, let's go ahead and to find out what cosine is. Cosine in this one is going to be square root of 6 divided by 3 squared, and minus sine squared, which was negative square root of 3 over 3. Now, square these. Remember, everything gets squared. What do I mean exactly? Negative 6 squared, 3 squared, negative square root of 3 squared, 3 squared. This is going to become, these are going to cancel. It's going to be just 6 over 9. Those are going to cancel as well. It's going to become 3. And remember, negative, negative make a positive, so that's the reason why that's left as a positive 3. This will be 9. This is going to subtract to give you 3 over 9, which reduces to a third. And that's your answer for this one. Now let's get into half angles, but I'm running a little short on time, so I'm going to skip the half angles. I want you to do the half angles, but I want us, but use the other example as your learning guide. Now for question 3, there's only one thing that needs to be done with this. I know most of y'all are probably confused about how to get this one done. Now first of all, secant in itself, what am I given? Remember, secant is giving us values. Which ones? Secant is the opposite of cosine, which means that you have hypotenuse over adjacent, which means you're given 3 over 1. Now, that's important to know. The reason being is that you still could find out what cosine is. Cosine theta, actually you already know what it is, it's going to be 1 over 3. It's adjacent over hypotenuse. So if you notice, it came from here. You just flip them pretty much. You flip the values and you're there. But you still need to find out what sine theta is and tangent theta. Now, you know that you have opposite over hypotenuse, and you know you have opposite over adjacent. Now, the thing is that where does this angle lie? Now, one thing that's important, sine is positive. You know, if you look at your unit circle, sine is positive only at the values between pi to 0. So only the top part of the unit circle. And since you're figuring out that the adjacent is positive, means that it kind of rules out this, because remember, this is related to secant. So your central angle is going to be here, quadrant 1. So when you draw this angle here, your angle there, your adjacent is going to be 1, hypotenuse is going to be 3. You go ahead and get your opposite pretty easily. Leg squared plus leg squared is equal to hypotenuse squared. 1 plus b squared is equal to 9. Subtract 1, those cancel. B squared is equal to 8. Take the square root of both sides, you find b is equal to square root of 8, which in reality is the square root of 2, square root of 4, which means you really have 2 square root of 2. That became this. This one I just change the order of it. So from here, you're actually given the now opposite side. This is equal to the opposite. Right, OP. Okay, so from here, hypotenuse I know is 3 on this. This is 2 square root of 2. And then from here, this is going to be then adjacent, which is 1. Opposite was 2 square root of 2, which means this is really 2 square root of 2. From here, now you could go ahead and use all your identity properties to solve this one. Okay, let's move forward with the review. Now with this one, figure out the cotangent. Remember cotangent, what values are given? Cotangent in particular, cotangent theta is really equal to adjacent over opposite. Now, one of these is negative, so this is really 2 over 1. I'll put the negative there in the middle because I don't know which one it applies to. Now we have to go back to find out when is the secant values basically less than 0. Like when are the secant values negatives? Well, one thing we got to keep in mind. First time we got to keep in mind that secant is related to cosine, so we want to have 1 over cosine theta, and I want to find out when is that less than 0. So for this, let's go ahead and kind of bring out the graph and calculator and get a better idea when is that possible. Let me bring out this. if it's functioning. Let me close it. It seems like it's bugging a little bit. This one bugs a bit sometimes when it's not in use. Or if you want, let me go ahead and look at the unit circle, and I'll tell you which ones they are. Okay, it's going to follow the same. In this case, that as far as cosine, cosine is negative. In the unit circle, cosine is negative in this side of the unit circle. Quadrants 2 and 3. The other two quadrants are positive. So which means that the center triangle needs to lie somewhere in here. Now, since I'm given that one of the sides is positive, means that in this case, to make this work, it has to be this top one. Why? Because when you draw the central angle, if it's over here for some reason, it's no here because they can't both be negative. Remember, this quadrant is negative, negative. One of these needs to be positive, which we know is the opposite. So this is going to be 1, this is going to be negative 2. So from here, the only thing you really got to know, well, you know what tangent is on this one. Tangent is going to be, of theta is going to be opposite over adjacent. So in this case, it's going to be negative 1 over 2. I still need to find out what sine theta is, and I still need to figure out what cosine theta is. But once you have these, then everything else becomes a breeze. Opposite over hypotenuse, adjacent over hypotenuse. Opposite in this one is going to be positive 1, because remember we defined that the a is negative 2. So this one's going to be positive 1, and this one's going to be negative 2. What I don't know is what's the hypotenuse. If I can use Pythagorean Theorem, 1 squared plus negative 2 squared is equal to c squared. 1 plus 4 is equal to c squared. 5 is equal to c squared, the square root of this. C is equal to square root of 5. Now in this case it's positive because hypotenuse is always positive. Square root of 5, square root of 5. Same thing you need to do, just rationalize it. Multiply by the square root of 5 over the square root of 5. Multiply by the square root of 5 over the square root of 5. Square roots cancel out, negative 2 square root of 5 over 5. Square roots cancel out, square root of 5 over 5. So you have your other angles, you have all three, to go ahead and successfully complete the other problem. So I challenge you now to go ahead and now do that. All right, let's go ahead and move forward and use half angle formulas. Now I only have time to do one more with you. And the one I'll do, what is this? The test for this is an awful lot like your assignment. You know what? It is your assignment. Thought this was a review. I'll still post this up because for some reason it says assignment 12, but it's not the actual one. But actually, I want to say that a lot of them went off this one. So let's go ahead and do the last one. The last one's going to be pi divided by 8. And to get this as a half angle, you're going to do like this. Sine, you're going to break this up. 1/2, and this is really pi divided by 4. Okay. So which means you have sine 1/2 theta. This is the same thing as sine theta divided by 2. It means the exact same thing. Since that's the case, that means that this is theta and this is a half, which means theta is equal to pi divided by 4. Now, what do we do from here? You take that and apply it to the formula. So we're going to have sine, and your half angle formula for this, I believe it's minus, so we're going to do the square root of 1 minus cosine theta over 2. Let me double check it's minus. It is, and the only thing that needs to be done now is apply 1 minus cosine of pi divided by 4 over 2. So when you look this up, when you look at pi divided by 4, you're going to find out you have 1. It's going to be the square root of 2 over 2. And that's over 2. And then you use your formulas to go ahead and solve all this. If anything, when you work on this one, this is just going to be 1 over cosine 7 pi divided by 12, which means you have 1 over cosine 1/2 7 pi divided by 6. So you do this half angle formula and you solve this one. Okay, great. I'll go ahead and post this one, and I'll try to I'll try to see if I can try to make one late evening. Well, I won't be able today till tomorrow. All right, thank you.